called reproductive magnetic large gate. This is also called MLG. Here is our outline, including introduction, and we will introduce MLG built by nanoduct, nanowire, and the thin films. Here's the categories of large gates. A large gate is a device that implements the Boolean function that it performs an electrical operation on one or more inputs and produce an output. Nowadays, large gates are composed of transistors or CMOS acting as switches. For a gate, only when both inputs are 1, the output will be 1. In other conditions, the output must be 0, like this. For NOT gate, it's opposite to AND gate, like this. For OR gate, its function is x equal to a plus b. It means that when one or both of the inputs are 1, the output will be 1. For NOR gate, it's opposite to OR gate, like this. For NOT gate, it shows the result of input and output are inverse, like this. For intrusive OR gate, only when both the inputs are same, the output will be 1. If not, it will be 0, like this. Here's the characterization of MLG. In electric gates, we define logic 0 and 1 by absence or presence of charge. That is on and off. In MLG, we define logic 0 and 1 by using direction of charges. That is up and down. Second, MLG merely flips the spin, and it doesn't have to move the charge. Third, the output is non-volatile and repeatedly readable without regression. Here's the MLG built by nanoduct. We could define logic is 0 and 1 by this situation because of shift anisotropy. Or logic is 1 when nanoduct's magnetization points to the right, or logic is 0 when it points to the left. Here, I want to make an MLG by NQCA. Before talking NQCA, I will introduce QCA. QCA is used in computation and is based on Coulomb interaction of electrons confined in quantum dots. Here is the typical QCA structure. It contains 4 quantum dots and 2 electrons. For NQCA, it's similar to QCA. It consists of 4 nanomagnets and 2 polarized up and 2 polarized down. It's based on magnetic interaction. So there are 2 stable states. We could define logic 0 and 1. Later, my group member will introduce majority large gates or NQCA in more details, like this situation. Here's the MLG built by nanowire. We could define logic 0 when domain wall motion is opposite to wire's magnetization, and the logic is 1 when domain wall motion is in the same direction as wire's magnetization, like this situation. Here, I want to make a NOT gate. In this figure, here is the nanowire, and there is the domain wall. At first, we give a rotating magnetic field to make the domain wall motion. So the initial input is 1, because both of the domain wall motion and the wire's magnetization is points to the right. After going through a Q point, the magnetization between P and Q are continuous, like this. So the output will, so when domain wall arrives at R point, the output will be 0 because of the domain wall motion and the wire's magnetization is opposite. Here's the MLG built by thin film. Here is an element included 2 magnetic layers and a tunneling barrier. Besides, it layer has 3 inputs, A, B, C, and 1 output. For input, we could define logic x0 when current is negative, and logic x1 when current is positive. Note that current A and the current B together are able to rotate N1, but not N2. Only current A and the current B can rotate N1. For output, we could define natural 0 and 1 by two stable states, like this, parallel state and anti-parallel state. That is low resistance and high resistance. Here I want to make N gates. There are two steps. The first step is called state to determine what's the original state, this or this. For N gate, I want to use the anti-parallel state. The second step is called logic to decide our output by using current A and current B. For instance, when both inputs are positive currents, that is, both inputs are 1, they can rotate 1 to be positive, like this. So the final state is parallel state. The output is 1. Besides, if the inputs are 1 and 0, they can rotate N1. So it's still the anti-parallel state. The output is 0. So the result is the same as N gates. Later, my room member will introduce the accused.